If you discontinue watching this video, then please tell me what it was so that I can improve. But otherwise, I am trying to learn hydrology. Hi, welcome. I'm trying to learn hydrology. Today, the cohesion of water molecules or something. And after we've done it, we're going to do squat training. And if you participate in the squat training, then it's at your own risk. Now, we read this article here about the cohesion of water molecules in another series in biochemistry. But there was something interesting written about the surface of water, why water surface doesn't break that good. And now we want to concentrate on that here in hydrology and try to get these informations. Now, cohesion of water molecules. The hydrogen bonds that link neighboring water molecules give water considerable cohesion, the tendency of like particles to stay together. Okay, the answer is basically, do we say here, because these hydrogen atoms in it have a high tendency to stay together, these cohesion between the hydrogen atoms, which are part of the water. The cohesion of water molecules creates a very high surface tension, a measure of the difficulty of stretching or breaking the surface of a liquid. Okay, they have cohesion, and cohesion is the tendency of particles which are the same as the other ones to stay together. And water has a high one of it. That gives it a high surface tension because at a boundary between water and air, so a glass full of water, water's surface tension is very high because the water molecules are much more attracted to one another than they are attracted to molecules in the air. And there's the answer for us. Okay, cohesion seems to be something which all elements have to have. Cohesion, that is the tendency of these atoms to stay with atoms together which are the same as well. So hydrogen atoms try to stay together with hydrogen atoms. And now water has a high surface tension so that it does not break over the glass at the top so easily, because these hydrogen elements want to stay together with hydrogen elements much more of the water than we want to team up with or bound up together with the one of the air. And that is our answer. The influence of water's surface tension on the body can be seen in the way it increases the work required for breathing. The air sacs of the lungs are coated by a thin film of watery fluid, so each inhalation must be forceful enough to overcome the opposing effect of surface tension as the air sacs stretch and enlarge when taking in air. Now, the anatomical part, do we understand? There are inside of the lungs millions of these alveoli, these little air sacs, and if a person breathes in, they are getting bigger. And then inside of them there's a membrane, and on one side there's oxygen, and on the other one the carbon dioxide. And by opening them, there's now an exchange, and the carbon dioxide goes now out. So the oxygen was breathed in, and the oxygen goes then in the blood. So we don't completely understand it. Goes then into the blood and goes then through the body, through the blood system. And after it was used up, it comes back to the alveoli as carbon dioxide, now the waste product. And now in the alveoli on the one side the carbon dioxide, on the other one the oxygen, it is now replaced, and the carbon dioxide is then breathed again out, and the oxygen new in, and so on. And these alveoli are surrounded, is written here, by a little watery fluid, and this water has a surface tension. It wants to stay together, so a person has to breathe in, so that we're actually opening and overcoming this water tension which is just around them. Now we don't really understand now the physiological part behind it, what that now means. But we're here for hydrology. So we're just here for having one answer, one explanation, which was named here. Maybe there's a better one, of why water has surface tension and does not fall over if you make it a millimeter over the top of the glass. Now we have it now. The answer is, so I try not to rehearse a bit, the answer is that the hydrogen in the water has cohesion, and that is its tendency to stay together with other hydrogen atoms. So one hydrogen atom wants to stay together with another hydrogen atom. And now if they are in a glass of water, these hydrogen atoms of the water have a very strong tendency to stay together with the one of the water, and only a very little one, or not at all, to the one in the air. So they want to stay very much together with one in the water, and so they can rise a bit over the surface level of the glass. I think these are the two explanations. Now, I have there now a second camera, which I'm going to start now and I try to set now. The hydrogen atoms inside of the water, they have cohesion, and that is their tendency to stay together with other hydrogen atoms. So two hydrogen atoms want to stay together and don't want to come to another one. And now if a glass of water is filled over its surface over the top level, then the water molecules, so the hydrogen molecules, want to stay together with one of the water, with the other one in the water, the other hydrogen elements. And they don't want to come so much together with one in the air. So the hydrogen atoms just at the surface, at the point where they would fall over, don't want to go to the air. They want to stay together with one of the other hydrogen atoms inside of the glass. And so the surface level can be raised above the top level of the glass for some time. And that is according to Gerard Tatoga and Sandra Grabowski's Principles of Anatomy and Physiology book, page 40. I'm going to stop the camera. And that was the hydrology part. If you were here for hydrology, you can go directly to the next part of hydrology. If you stay here and participate in the squat training, that is when your arm risk. We are bringing one leg up. Pull the leg up, point with the toes down, and relax the leg. Other leg. Pull the leg up, point with the toes down, relax the leg. And now to the side. The toes are pointing forward, and we're stretching the inner side of the leg. And over to the other one. And now to the squats. So legs wide apart, and we're doing 12 squats. So to the first one, and to the second one. And on with number 3 and 4, and also number 5 and 6. We're having the half. So 7 and 8, last 2 to 10, 9, and now 10, and now only 2 more, 11 and 12. And now the next exercise, the 6-pack squat squeeze. So we're going down into quarter squat and pressing against the top of the leg, only on one side. And on the other side, only with one arm. And now halfway down, half squat, and press in the middle of the leg. And on the other side. And now 3/4 squat and press close to the knee. And on the other side. And up again. And now the fastest giraffe of the water pond. Down into 3/4 squat, press against the knee and go towards it. On the other side. Press against the knee and go towards it. Again, press. Go towards it. And again, press. Go towards it. And again. And last one. And up. Last exercise. The propeller. Down into full squat. Arms to the side. Over to one side. Press against the leg and look up to it. To the middle. Off to the other side. Press against the leg and look up to the hand. Into the middle and up. And we're ending. Again, one leg up. Pull the leg up. Point with the toes down. Relax the leg. Outside. Pull the leg up. Point the toes down. Relax the leg. And now take the leg at the ankle. Make a straight back and point with the knee down to the ground. Other knee, other leg. Straight back and knee down to the ground. Legs wide apart, breathing out down. And breathe again out. In and up. Out and down. Breathe in and close the legs. And breathe again out. That was the squat training. Thank you very much and until next time.